Hi folks, here we are again. It's good to see you. Hopefully if you've seen part one of how I made the hydraulic drawbar for Sally the Sile here, you'll be interested in seeing part two. So here we go. Roll the titles and I'll see you on the other side. Here we go again. These are the parts I'm going to be using to make the power cylinder for the power drawbar. There's 3 slugs of 76mm mild steel. This is the plate that fits on the top of the mill used from a previous attempt at the drawbar. I'm just reusing it. The first slug sits on the top and can move up and down with some springs so that it doesn't, when this thing operates, it doesn't trash the bearings in the mill. In the middle of that sits this part, which is the top of the drawbar, and then on top of that sits the Belleville springs. Moving up, we have the parts for the power cylinder. We've got a base to hold it from falling to pieces, the cylinder itself, and the plug that goes on the top. This is all to be machined, obviously, and made a lot shorter. It only needs to move 2 or 3 millimeters. I think I designed it to move 5 in the end. So that's the basic setup for this power cylinder. The whole thing is held together with these M5 screws, so it's going to look a little bit like a birdcage when it's done. Yep, good. Yeah, there you go, you old fusspot. Eh? Look at this. I think that's probably good enough. Next up is to use this insert parting tool to cut the O-ring grooves. Talking of the O-ring, this is what I've come up with. I'm going to use 2 of these. They're 4mm 42 diameter, internal diameter O-rings, and this is a cross section of what I'm going to do. So I'm going to give them 4.5, find a focus point, 4.5 mil of wobble room, although they don't need it because they're static. These are not moving. This is a plug basically. So we're going to go in 2mm, plunge in to give a diameter of 42.3, which gives me a little bit, a third of a mil of squish, if you like. I'm hoping that a third of a mil is going to be enough. I'm going to machine the first groove and then try it. And if I think I need to be a bit tighter or a bit looser, then I can make adjustments on the next one. So yeah, let me get on with that. I will cut these off camera because it's basic turning and I need to concentrate because I must get these diameters as accurate as possible. Okay, 2 O-rings cut and hopefully the flanges all polished. So let's try and see if we can get the cylinder on. Oh, yeah, cock on. There we go. Job done. Okay, so that's the bottom of the cylinder that's going to stop it falling out, and the top of the cylinder done. Now I need to fit the inlet nipple for the hydraulic oil, and I'm going to have a bleed valve in here as well so you can get the air out of the system. So that's next. Okay, that's that done for now. We'll just try There we go, drilled and tapped for a 1/4 inch hydraulic hose, or nipple, a 1/4 inch nipple I should say, for a hydraulic hose. I'll have to work out exactly what I'm going to do about the bleed screw. Might just be a screw with a copper washer under it. Yeah, I'll have a think about that. The best way to do it, because that's also going to be the fill hole. So yeah, need to think about it. Anyway, more to the point, that piece is done as far as it can be for the moment. So let's put that to one side. This is the next piece. Excuse me. This is the plate that bolts onto the top of the mill. There's a hole for a sensor in the bottom. I've used this in previous drawbars, so yeah, rather than make another one, I thought, sod it, I'll just use this one again. So first up is to take the slug that's going to be the bottom and face it off and turn it so it fits in here. Then I can use the existing holes to mark the position of the holes that I need to then drill in here. So then I can face that off. So let me go and do that. Right, so there we go. That fits on there snugly. Now if I clamp these together, I can just mark these holes for drilling. There we go. Okay, drilled out clearance, so clearance M6, so that's 6mm, and that they should fit in. So these are again off a previous drawbar, so there we go. That's the lifting mechanism, if you like, that way. Here we are again over at the mill. I've aligned, these holes don't need to be too accurate, so I've just aligned a point in the quill and a point in the chuck on my rotary table. So if I just spin that and spin that, hopefully you can see that they're more or less in line. I need to make this, I need to put some, I'm going to use M5 tie rods. Now according to the calculations, M5 tie rods, I'll go and get one. There we go, M5 tie rods are going to go in like so, to the top of the cylinder stack and then be locked off. According to the specs, they should be good for a minimum tensile strength of 600 kilos, which means that spreading the 1.2 to 1.5 kilo load is going to be not sufficient, but that is the minimum tensile strength, so hopefully I'll be okay. I've plunged the tool, this marker, into the top of the work because I'm going to face it off again anyway, and made some scratch marks so that I can just check my diameter, because I need to get this as accurate as possible, and I am indeed on 68. Let's put the old spindle on. Not going to worry about coolant. And we have, yep, we're there. So let's just and go round to minus 100 or 120 degrees. There it is. Right, this is the problem, and I think I have a solution as well. The chuck on that rotary table is can only really cope with about 74mm, so it's just on the edge of what it can cope with, and one of the jaws is only just engaging. So if you can see, the gap there between the edge and the work is a lot smaller than the gap there between the edge and the work. The net result is that these holes are in the right position but shifted over. So what I'm going to do, I can hold this part easily, so I'll drill the right holes in here and then use it as a template for this one. Once I've done the holes in here, we'll use it this way up, so you won't ever see the fact that I've blown out these holes, or I just face them off until they disappear. Okay, I've drilled all the holes in that plate, faced it off again to get rid of the remnants of the holes in the wrong place. So I thought we'd just have a quick demonstration of the stack up here. So this plate fits to the top of the mill. This plate screws on with these three. There you go. These three sprung loaded screws, so that plate can move up and down. In these holes, I haven't got enough space to get these in, but these 6 M5 screws fit in on top of that, tie bars I should say. So let's take that out. Floating, here's the drawbar. That's rough idea of what the drawbar is going to look like. This plate is there to retain, or this ring is there to retain the cylinder, so the cylinder doesn't fall. There'll be a piston in the middle, so the tie bars go clean through this, and here's the top. Oops, and just put it on roughly the right place. There we go. So there's the top. So the bars go through here, and then the nut attaches to the top, and they're held at the right height to the piston, when it's at its full extent, has just compressed the disc springs or Belleville washers enough to release the tool, because we only need a couple of millimeters at the most to actually release the tool. So the next thing to do is to shorten this piece of cylinder. So I've worked it out, and I think I'm going to go for about 50mm, 2 inches. So let me get on with that. There we go. Now I can make sure that I'm not too adrift when I cut it on the bandsaw. Right, there we go. We'll just face that off to length and tidy it up. You have to forgive the sound outside. It's my daughter with the lawn hoover. Not something you see very often. There you go. I find these round profile tools give you an absolutely excellent finish. It's actually, this is an aluminium insert, but it works quite well and gives you a superb finish. Look at that. There we go, that's the cylinder. I've had a bit of a thought. If I've got space here to put one more set of holes, so I could make this a self-contained cylinder. At the moment it's designed so that you have lock nuts that jam the two bits together, but that makes it all tricky to fit. I can make this a self-contained unit if I put another tie bar there and there, and just clamp this together. So I'll do that, but I'll do that off camera, because it's only trying to work out my indexing points again, and then just drilling another 6 holes. The ring has now been tapped. The top has been drilled. There we go. 3 nuts. I made some, I don't know if I can show you that, but I made the countersinks bigger on those holes, so we know which ones to use in the future, because this will index round to any of those positions. But because I picked these holes up afterwards, there's every possibility they're going to be in the wrong place. But there we go. That is our little power cylinder. So this is the setup. I can put a single one of these in, because I haven't cut the rest yet. I don't know the length of them, that's why I haven't cut them. That hole should do us. Whoops. So there we go. The piston pushes down on there, clamps this whole lot together and squashes it down. Spot on. That's quite a compact unit. I'll give you some kind of scale. That's a 6-inch 150mm rule. So we're not talking anything huge here. Here's the same 6-inch rule. There we go, that's on the, I can feel the magnet in there, that's my magnet centre, that's the top of the drawbar. So it disappears almost completely. Should work just like a brake, a car brake caliper bleed nipple, in order to fill the cylinder up. So now I need to make the reverse to go in there. After 2 hours of cutting this groove and polishing, I think I finally have the right diameter and width. So it's all ready to just turn this round and face the other end, and then piston's done. I have cleaned the cylinder down, dismantled it from our previous test last week. The piston, the power piston, has had another ring cut in it for another O-ring to assist with the sealing. The damaged lip seal has got a new one, and since last time I've also cut this groove in the bloody flies back. Cut a groove in the top of the piston in order to connect this hole with this hole, so that the oil can be bled out of the system. Otherwise, when the piston hits the top here, it jams both holes up, so no oil can flow. So you can't necessarily get the oil purged, the air purged out of the system. So I've added that as well. So just need to reassemble this, bit of oil, bit of assembly, and we'll have another go. Fitting the first seal, which I've had to destroy to get it off. I've thrown it away, I think. Stretching it over this piston was tricky, so I've looked on Tinternet, and there's a special tool to expand these to fit them over there. I don't have one, so I've made one. This is the spare bit of the hydraulic piston, hydraulic rod, and I've put a taper on it, I think about a 10-degree taper. So in theory I should be able to just force this down onto here, right the way over to the other end, and then drop it off, push it into that groove. So let me get some oil on that and we'll give it a go. Attempt number 2. Would you believe the cylinder is in good nick? Even though I've just dropped it onto a, well, I've got a rubber mat and some hardboard down here that's on the floor that's been there for years, and it's very good at just absorbing a few impacts from things I've dropped over the years. So there we go, that's on. Now this time let's push it down to the bottom. Oh, there's a stiff bit there. Oh. There we go. Oh. Well, there we go. Buy that, wouldn't we? There we go. Job's a good one. Right, so this should now fit nice and neatly. This is bound not to work. My craptacular power supply, ready for the wires for the motor, for the linear actuator. It's fully down at the moment, in other words the piston's fully in the bottom here. Here is the core inch nipple. Oh, there's a pussycat. Stuffed in the centre of that is a piece of model aircraft fuel tubing, the other end of which is in the tank of compressor oil. So let's see if I drive the piston that way with the power supply, whether we can fill it up with just drawing the fluid in. Right, here goes. Hey, what do you know? I don't know if this makes any sense at all, but to try and fill the hose, I'm going to take the model aircraft tube and stuff it in the end of the fitting, and it goes all the way down to a catch can down the bottom there, otherwise known as a pickled onion jar. So let me see if that works. There's still air in the system, but I have managed, I think, whilst the drive piston goes down and out comes the power cylinder. If I reverse it though, there's clearly air in the system still. Drawbar is loose. Let's just see if we can squash it. Oh yeah, that's definitely squashed. No leaks so far. No leaks this end. No leaks this end. Right, excellent. Let's try and release it. There we go, released. We'd buy that. Hey boys, we're there. The U-cup version of this cylinder isn't retracting properly. It's cavitating the fluid, the oil. So I thought I'll try one with lower frictional resistance. So I've made off camera, I've made another power piston out of the remaining bit of stock. So if this doesn't work, we'll have to think of another way of doing it. But this is designed to fit 2 O-rings. So it should have, and I've only gone for about a 10 to 15% squish. One's 10%, the other's 15%, in order to try and maintain a seal. So I'll put this together and put it on the actual the power cylinder, and we'll see if it holds pressure to start with, then see if it actually retracts properly. Okay, which one's the top? This is the top, rather than the bottom. I'm going to have to resort to Harry the Hammer there. There we go. That's got a lot less resistance. We know resistance is futile. Okay, so I've just assembled it and laid it so you can see. Let's drive it out and watch that. I think there's still a bit of air in the system, but not overly bothered about that at the moment. There we go, fully out. And it also seems to retract quite well. You can see it's cavitating because the piston is still going in, and the drive piston has stopped. So it's the vacuum or the air pressure is pushing that in quite slowly. I do wonder whether we'd be better off with a thinner fluid. I I'm using something called compressor oil because that's the closest thing I've got to hydraulic oil, and it's quite stiff. This is the original fluid out of this hydraulic jack, and apart from being absolutely filthy, it is quite thin. So I might see if I can source some of this. Last time I looked, I could buy it in like 25 litres. I need about 1/4 of a litre, so 25 litres is a bit much. Here we go. The cylinder is mounted above here. I've given you a close-up so you can see so we can all see this happening. There's the stack of Belvilles. This spindle can rotate. I'll just change the direction of the power supply and scarper because I don't want to be here. There's a lot of pressure in this. Okay, that's fully pressurised, and that's put a fair bit of pressure on those springs, so let's just reverse it and see if it goes back the other way. Oh, the battery's about to die, but there you go. Held the pressure, and this is free to rotate again. I think we're there. I'll fit it to the mill. There's the motor, there's the top of the spindle, there's the drive belt. You probably can't see that very well, but I made this aluminium plate that's got a little neodymium magnet buried in it, so for every revolution it passes a sensor, and this was the original magnetic sensor. Right, this is a spare sensor. It's an AN9109. It's obsolete now. It's a Matsushita, which is Panasonic. It's just a magnetic sensor, and so it's designed to fit in this plate. This is the base plate for the power drawbar. I'll fit it in there in a second. So every time this goes the other way up, and every time the magnet goes over this cross, it gives a pulse, and that is fed to Mark III. So let me just install that, and then we'll go and put this plate in the mill. There you go, installed. Okay, now we've got the plate in. Next is the clamp base, which fits on there like so, and the 3 screws that hold that in position. Okay, next is the clamp piece from the top of the drawbar, top of the spindle. That can rotate, but if I just put one of these in fact I'll put 2 in, this plate lifts, and in doing so clamps the top here. Right, next are the support bars. I've got the cylinder, and let's just put it that way around. This was my thought on how to set it. I can get it on, there we go. It's just touching it's fully extended, just touching the top of the drawbar. So we're going to set these nuts at -2mm, so and then clamp it all in. Power drawbar is underway. There we go. The tool is well and truly released. Bloody fantastic. There we go. Right, let's try clamp the tool in. Do you know, I think we'll buy that. The world's cheapest power drawbar. Probably also the world's quietest power drawbar. You can barely hear that. Incredible. 1.5 tons of force generated for about $100 pounds. You can't go wrong with that. Right, thanks for watching. That's the construction finished really on the power drawbar. So we have a working machine, which has got to be good news. I've got a, you can't see it, but down on the floor here is a foot switch. So it does operate well with a foot switch. So yeah, all in all, quite good. There may be a follow-up video in this on in a couple of 3 weeks once I've finished the some modifications that I wanted to do to it. I'm thinking about putting an Arduino on to reduce the travel even further on the drive cylinder, which will speed it up. So bear with me. I'll see if I can put that together, and please hit the bell and subscribe button, and we'll see you on the next one. Take care. Bye bye.